Okay, so did you get number 10?
I was working on it, but I don't think I.
Working on it.
Right.
Okay. Emma, how did you? Oh, I lost Emma. Okay. All right. So you have a 500 space parking lot. So the total number of vehicles you can have in that parking lot is 500, right? So the first thing that you do is you have to make your defining statement. Your defining statement just helps you to understand what X and Y are going to represent, okay? All right. So if that's the case, okay, the total number of parking spaces, so the total number of motorcycles and the total number of cars, when you add them together, right, has to equal what?
1,650.
No, that's the number of tires that there are, right? Hello again, Emma. How many parking spots are there?
500.
500. So in total, the most amount of cars and motorcycles, when you add them together, is going to give you 500. Right?
Yeah.
Okay. So I'll leave this up here for you to write down. I just want you to follow along with me. So now, how many tires are there on a car?
4.
And how many on a motorcycle?
2.
So if I have one car, how many tires do I have?
4.
And if I have one motorcycle, how many cars do I have? Or sorry, how many tires do I have?
2.
Okay. So I take the number of tires on each vehicle times the number of vehicles, and that tells me how many tires I have, right? So if I have 100 cars, I have 400 tires, correct? And then I add 2y, and that equals, what is it, 1650? Yeah, and that equals 1650. You follow?
Yeah.
All right. So the first one is just adding the cars and the motorcycles together because that's the number of parking spaces there are. And then the second one is to work with just the tires themselves. All right?
Okay.
All right. So what I'm going to do this morning is I'm going to go through those 5 questions with you, 11 to 15, and I'm going to help you set them up. Okay? Because that's the difficult part. All right? The setting up the part is the difficult. Can you solve them? If you have them set up, do you know how to use the elimination method?
Yeah.
Okay. So we'll worry about that after then. So let's look at 11 now. All right? All right, number 11. General admission tickets to the Calgary Zoo cost a total of $109 for a group of 4 adults and 3 children. Tickets for a group of 2 adults and 5 children cost $93. What is the cost for 1 adult? Okay, so let's just look at the ticket cost now. All right, so the first thing I'm going to do is write my defining statement. Statement, X is adult, Y is child, right? Okay, and that's going to be the cost of each one, correct? So I have 4 adults and 3 children, so I go 4x plus 3y, and that tells me how much it costs, $109, right? So Emma, were you able to do number 11?
No.
No. Okay. So do you follow that first step then?
Yeah.
Okay. So if that's the case for the first step, what do you think the second equation is going to be then?
I have no idea.
Okay, so what does X represent? X represents the cost of an adult ticket, right?
Yeah.
And Y represents the cost of a child's ticket, correct?
Yeah.
So let's say an adult ticket costs $10 and I had 2 adults. How would I find out how much it costs total?
10x or 2x?
Okay, so I'll just think about what I'm asking you. If it costs $10 for an adult ticket and I sold 2 tickets, how much would it cost?
20.
20. So you're taking the number of adults times the cost of the tickets, right?
Yeah.
Okay, so the cost of the ticket is X, and I have 2 adults. How do I find out how much it costs?
You cut out. I didn't hear you.
Okay, that's okay. I said the cost for a ticket is now X, right? And I have 2 adults. How do I find out how much it costs?
5.
Right. So how do I write that in a statement then? If I have 2 adults and 5 children and the total is $93.
Yeah.
Okay, that's all right. Avery, do you have any idea?
No.
No. Okay, so we got to backtrack a bit here, girls. All right, because I'm kind of losing you. So here's what we're going to do. All right, now, okay, both put your mics on mute for a second. All right, so X is the cost X is the cost of an adult ticket. We know that. So to find out how much it costs for adults to go to, the zoo, right? We're talking about the zoo. To find out the cost for the adults to go to the zoo, you take the number of adults all right, so I take the number of adults that I have and I multiply it by the number or the cost per ticket. Okay? So to get my cost then, it says that I have 2 adults. All right? I have 2 adults, so the number of adults is 2. And the cost per ticket, we don't really know, but we said it was X. So I put 2X down. All right? Now I'm going to do the same thing for the children's one. The children one is Y. That's what it costs for the ticket. And I have, how many children do I have? I have 5 children. So I take the number of children times the cost per their ticket. Well, the cost for their ticket is Y. So together, if I knew what the cost of the adult ticket was and I knew what the cost of the child's ticket was, they would add, and that would give me $93. So how do I show that in an equation then? 2X plus 5Y equals 93. Okay, morning, Myra. All right, so we're going to unmute this now, girls. Avery and Emma. Do you follow what happened here, or do I still need to do a better explanation?
No, that makes more sense.
Emma, are you okay too?
Yeah.
All right, so you understand what I'm saying. So sometimes in these questions, the best thing that you can do is write it out to make sense of it first. So I write out, how do I find the cost for a family to go to the zoo? Well, I take the number of people and I times it by the cost per ticket. But the number of people, the number of adults, and the cost for an adult was different than the children. So I take the number of adults and I times it by, so I go 2x plus 5y equals 93. In the first one, I had 4 adults, 3 children, and it cost $109. All right? Okay? So again, I'm not going to solve these for you. I don't want to solve them. I just want to set them up. And so my suggestion is I'm going to go through and set up the next 3 with you. What you should do is later today, go back without any notes, read them again, and try and set them up again. Okay? Myra, how did you make out with questions 10 to 15?
I made out well. I don't have any questions.
Okay, so what I'm doing right now, Myra, is I'm just going through and setting up each of the questions to make sure we know how to do that correctly. Okay? So, question 12. John lives 1.2 miles from his school. Each morning he walks the entire distance in a time of 24 minutes. On his return each afternoon, John runs part of the way so that it takes him only 15 minutes to reach home. If John runs twice as fast as he walks, how far does he run on his way home from school? Okay. So again, my defining statement. This one's a tougher question because you really you need to know a little bit about the physics. All right. So this is X is going to represent the speed he walks at. And then Y is going to represent the speed that he runs at. Okay? So we know how long it takes. So the first thing I've got to do this. I don't need to get too technical with physics, but distance. To calculate somebody's distance, I take the speed at which they're moving at and I times it by their time that they do it for. So my favorite thing to get this across when I teach this in grade 9 or 10 science, or I teach it in grade 11 physics, my statement is always this: if I'm moving at 100 kilometers an hour for 3 hours, how far did I go? Well, you take 100 kilometers an hour and you times it by 3 hours. You went 300 kilometers. So that's the way I teach myself to remember, how do I find the distance? Okay? So in this question, it says he lives 1.2 miles. If I take in equation A, it takes him 24 minutes. So I take 24 and I times it by X, because that's the speed he walks at. And that's going to equal 1.2 miles. Okay? On his return each afternoon, John runs part of the way so that it takes him only 15 minutes to reach home. If John runs twice as fast as he walks, how far does he run on his way home from school? Okay. So he's going to run twice as fast as he walks. So his running speed would equal 2x. All right, now I don't want you to write this down yet because we've got a bit of a mess at the moment. Okay, so I don't want you to write this down. So it says John lives 1.2 miles from his school. Each morning he walks the entire distance in a time of 24 minutes. On his return home each afternoon, John runs part of the way so that it takes him only 15 minutes to reach home. If John runs twice as fast as he walks, How far does he run on his way home from school? Okay, so if I was to use the distance part of this, all right, the issue that I have here is I've got a speed, I've got a time, and I got a distance. Here I have just two speeds. So is it possible for me to sort this out with the way it's written? The answer, of course, is no. Okay, I can't do it this way. So I've got to figure out how am I going to do this? Do I need to use the distance, or do I just work with the time? That's what we want to know. Okay, so on the way home, just going to go back to this for a second. If I was talking about just distances and on his way home, so I'm going to go back here. On his way home, that would mean that he walks a certain speed and he runs a certain speed, and I'm going to get 1.2 miles. So now I'm going to arrange this differently. I can do this a little bit different. I can work with speed now, and I can take distance over time. So his total speed run and walk together is 1.2 divided by 15 minutes. Okay? So now I am working with just speeds. So if I work with just speeds, okay, I can also say then that y is equal to 2x. Now I might be able to solve this question. All right? So I can work with this way. Okay, that's one way to do it. But I still have that 24 minutes in there. So I've got to figure out how that 24 minutes affects anything. Well, if he's walking, can I find it by doing this? All right, that's the question that I got to be able to answer. Can I find it if I have a distance over speed? Or a distance over time, sorry. All right, so I'm going to set this up as is, and then I'm going to come back to this tomorrow with you. Okay, so this one is a little more complicated than the ones that we've already done up to this point. All right, so we'll come back to this. That was question 12. So we got to come back to this one tomorrow. Okay, so I'm going to look at 13, and then I'm going to leave 14 and 15 for you. So the Golden Ears Bridge is a toll bridge across the Fraser River in British Columbia. It connects Pitt Meadows and Maple Ridge on the north side to Langley and Surrey on the south side. The regular toll for passenger cars is $3.95. The fee is reduced to $2.80 if a vehicle is equipped with an electronic transponder to pay the toll automatically. One day, 8,200 cars cross the bridge. Defining statement. No transponder. Transponder. Okay. Between X and Y, there were 8,200 cars that passed that point. So total number of cars, X plus Y equals 8,200. Now I'm talking about the money. Okay, one of the three of you, help me out with this next part now. It says the regular toll for a passenger car is $3.95. The fee is reduced to $2.80 if it has a transponder. The total amount of money is $30,032.50. Come up with an equation for me. So write one down on a piece of paper, and then I want somebody to tell me what it is. Okay. Go ahead and let me know how this is going to work. Myra, Avery, which one of you can, or both of you? What do you think? Oh, Myra, I lost. Avery, you still there?
Yeah.
Okay, I lost the other two. So the pressure's on you now. What are you thinking?
Would it be 395 and then plus 280? I don't know.
Okay, you're on the right track. All right, so if I have one car, how much with no transponder, how much is it going to cost?
395.
Okay, and how'd you get that?
Because it says in the thing the regular car is 395.
Right. Okay, so if I said to you, there are 4 cars with no transponder, how much would it cost? How would you find it?
You times it by 4.
Times it by 4, right? So if the cost was X, then how would you find it? Or sorry, if the number of cars was X, and I had $395 per car, how would you find out what the total cost was?
I don't know.
Okay, let's do this again. You have 2 cars at $395. How do you find out how much you're going to make?
You times it by 2.
Okay, you have 5 cars and it's $395. How much are you going to make? How do you find it?
Times by 5.
You have X number of cars and it's $395. How do I find it?
You just times it.
I'm sorry I missed that, but you take $395 and you times it by the X, because X is the number of cars, right? So to find out the total amount, you take $395 and you times X. The same thing goes with 280, except now I've got Y, because those are the ones with the transponder, right? So my equation then is 3.95X plus 2.80Y, and that is equal to, I gotta move this over. So when I take the number of vehicles without the transponder and times it by 395, and the number of vehicles with the transponder and times it by 280, I'm going to end up with 30,032.50. Does that make sense, girls?
Yeah. Yeah.
Okay. All right, so the same thing goes for 14 and 15. Basically what you're doing here, ladies, is you're going to consistently multiply by your X and your Y in order to get, if it's an amount, it might be a weight, it might be a distance, whatever. Your one statement is going to have a multiplication in it where you're going to times it by X, times it by Y, and it's going to give you a total value. The first statement is generally just adding them together to find out how many you have total. Okay? All right. So for tomorrow, go ahead.
Yep.
Okay, so for tomorrow, can you try and do 14 and 15 for me?
Yeah.
Okay. And then I'll look at those tomorrow, and then tomorrow I'm going to...
Okay.
All right. Have a good day, girls. We'll talk to you tomorrow, okay?
Okay, thank you.
Okay, welcome. Bye.